Hi, my name is Ling. I'm from the Chemical Engineering Department. This is my proposal defense for FYP 1. This is my title with the name Blended Nylon 66 and Amino Acid Based Ionic Liquid for Adsorptive Nanofiber Membrane on the Removal of Heavy Metals. This is the overview of my presentation. I'll start with an introduction, explaining heavy metals and ways of removing them from water bodies. I'll also talk about membranes and ionic liquids. Then I'll proceed with the problem statement, which are the issues that I would like to tackle. Next is the objectives and the scope study. I'll also touch on the literature review and my research methodology. Then I'll explain my research gap, followed by my expected results and conclusion. So what are heavy metals? Heavy metals are metallic elements that are high in atomic weight, and they also have relatively high density as compared to water. Some examples of heavy metals include copper, lead, and zinc. Heavy metals in general are relatively harmless, and in fact, iron and copper serve as essential nutrients to humans for biochemical and physiological functions in a low concentration. However, in high concentrations, they are potentially hazardous to humans and environment. There are several conventional methods on removing heavy metals from water bodies, namely the ion exchange method, chemical precipitation, and coagulation method. Apart from conventional methods, membrane filtration is also widely developed to be used in heavy metal removal process. Membrane is a thin layer of semi-permeable substance that allows certain materials to pass through it when a drawing pressure is applied across it. It is capable of removing suspended solid, organic compounds, and inorganic contaminants such as heavy metals. Depending on the size of the particle that can be retained, various types of membrane filtration such as ultrafiltration, nanofiltration, and reverse osmosis can be employed for heavy metal removal from wastewater. In this project, a nanofiber membrane is used to remove heavy metals from wastewater solution. Other than that, ionic liquids is also incorporated in this project as solvents. Ionic liquid can be used as ideal solvent due to their stability, low vapor pressure, non-volatility, and high thermal stability. The main advantage of using ionic liquids is nanoscale and microscopic fibrous material with high surface area can be obtained. In this project, amino acid-based ionic liquid is used for heavy metal ion extraction, as it can be used in a less harsh thermal and chemical condition. Its functional groups could also be used to chelate and extract metal ion as compared to the classic reaction media. These are my problem statements and proposed solution. Problem statement number 1. Due to Industrial Revolution, the concentration of heavy metals has risen to an alarming level. Natural occurrence such as volcano eruption and also anthropogenic activities like mining and smelting has contributed to heavy metals pollution. As an example, copper is usually found at high concentrations in wastewater because it is commonly used in many industrial applications. High uptakes of copper may cause liver and kidney damage. Besides that, conventional ways to remove heavy metals have their own fair share of disadvantages, such as cost-consuming, and they also have the possibility of generating secondary waste. For instance, just now I mentioned chemical precipitation and coagulation methods. They both have a similar disadvantage, which is the production of sludge, which requires additional cost to treat or remove them after the process. Thus, my proposed solution is to use nanofiber membrane to remove heavy metals. Problem statement number 2. Ionic liquids as the solvents suffer from poor degradability, or their degradation products could be toxic, limiting their use in various sectors. In this case, my proposed solution will be to use amino acid-based ionic liquid. Thus, the objectives of this project is to investigate the effect of blended amino acid-based ionic liquid and nylon 66 polymer on fabrication and structure of nanofiber membrane. The second objective is to analyze the characterization of nanofiber membrane and amino acid-based ionic liquid. And the third objective is to evaluate the performance of nanofiber membrane for heavy metals removal. So this is my scope studies, which includes preparation of amino acid-based ionic liquids with choline hydroxide and glycinate, Second, blending of amino acid-based ionic liquid with nylon 66 polymer solution. Third, fabrication of nanofiber membrane with the blended solution using electrospinning technique. Fourth, characterization of nanofiber membrane using field emission scanning electron microscope, FESM, dry wet method, water contact angle, and Fourier transform infraspectroscopy, FTIR. Fifth, determination of ionic liquid in the membrane by performing leaching tests with ultraviolet visible spectroscopy. And lastly, evaluation of nanofiber membrane performance by performing permeability tests and heavy metal rejection tests. So this is my literature review on conventional methods of removing heavy metals. The methods included are chemical precipitation, coagulation or flocculation, electrochemical, and ion exchange, alongside their disadvantages and advantages. Besides that, I also did a literature review on types of membrane filtration, which includes ultrafiltration, microfiltration, nanofiltration, and reverse osmosis. The type of membrane that I use is microfiltration membrane, which is the most appropriate in removing heavy metals. Next, on the electrospinning mechanism, nanomaterials with firmly controlled size distribution can be fabricated using electrospinning process. It consists of three major modules: a high voltage power generator, a syringe pump, and a collector. The blended solution of amino acid-based ionic liquid and nylon 66 solution will be placed inside the needle. When a high voltage is applied, an evenly distributed electric field is formed, and the liquid surface at the end of the needle is charged. The high voltage is to generate an electrical charged jet of polymer solution. Thus, the solution jet solidifies before getting to the collector, and an interconnected mesh of small fibers is composed. These are the factors that affect the outcome of the membrane, which are the applied voltage, solution flow rate, needle distance to the collector, and also the polymer concentration. Other than that, we have the applications of nanofiber membrane in various sectors, such as water treatment, filtration, biomedical purposes, drug delivery purposes, and also for protective clothing. And these are the different types of nanofiber membranes used in the wastewater applications based on previous studies. And also did a literature review on the different types of ionic liquids used in heavy metals removal processes, alongside their performances and description. This is a continuation of it. So previous studies have been done by using pure ionic liquids as solvents, and also fabrication of membrane using the immersion method. By that, we came to this research gap. Firstly, I use amino acid-based ionic liquids as a solvent in the fabrication of nanofiber membrane, specifically choline glycinide. Second, fabrication of nanofiber membrane will be done by the blending method, which is a blend between amino acid-based ionic liquid with nylon 66 polymer solution through electrospinning technique. This is my overall research methodology for FYP 1 and FYP 2. Research work and experimental work will be scheduled to be done in FYP 1, while the characterization and permeability test, analysis, and dissertation will be done in FYP 2. So for the methodology, the first step is to prepare pure ionic liquids. Basically, glycinide will be added to choline hydroxide to form choline glycinide. Then the solution will be stirred for 48 hours at room temperature and washed with ethyl acetate or acetone to remove excessive amino acid. Next, solution will be subjected to rotary evaporation and vacuum oven to get the products. Solution will be then stored in a dry box under argon atmosphere until utilization or characterization. The second step is to synthesize amino acid-based ionic liquid and nylon 66 solution. Basically, the nylon 66 pellets and formic acid as well as acetic acid will be added to choline glycinide from the previous step. Then the solution will be stirred for 12 hours or until homogeneous as preparation for the blended solution. And this is the fabrication of polymer nanofiber membrane with electrospinning technique. The blended solution will be placed in the syringe and table 6 is the detailed parameters for electrospinning. Subsequently, characterization will be done on ionic liquids and the membrane. For ionic liquids, the characterization method is NMR, which is to analyze the molecular structure of the ionic liquid. Next, I will also investigate the characterization of nanofiber membrane using 4 methods: FASEM, dry wet method, auto contact angle, and FTIR. Basically, FASEM is to determine the morphology by visualizing internal structure of a sample. Dry wet method is to measure the porosity of the membrane. Auto contact angle is to test the membrane hydrophilicity, while FTIR is to identify the chemical functional groups present in the sample. Other than that, I will also evaluate the performance of nanofiber membrane by performing permeability tests, leaching tests, and heavy metal rejection tests. And this is my current progress, which is still in step 1, preparation of pure ionic liquids. So this is the Gantt chart for FYP 1, and this is the Gantt chart for FYP 2. So both these Gantt charts is to ensure that I finish all my tasks on time. Lastly, the expected results from this project will be viewed from 2 aspects. Firstly, in terms of structure, I will hope to achieve a high porosity and large surface to volume ratio for the nanofiber membrane. Second, for the performance, the nanofiber membrane is expected to have a high permeability and high heavy metal rejection percentage. So these are my references for slides. And this is the end of my presentation. Thank you for listening.